Hey everyone, and welcome back to my channel. Ever wondered if your pure sine wave inverter is actually pure as they say? Well, today we are about to find out. We are tearing into the inverter to uncover the truth behind those specs. And hey, even if it's 6000 watt inverter, we have some fun testing it out with some components and other of my stuff. So buckle up and let's dive in. And also we'll be using some few tools to open up the inverter to actually see what is inside. Stay tuned to that. I hope you really got to enjoy it. And last but not the least, this hidden gem. Yeah, I'm not really going to talk about this product. Actually, it's actually blurry, but I'm going to talk about it more at the end. It's a very important role this is going to play while testing this inverter setup. So just stay tuned, and if you haven't subscribed, hit the subscribe button. Let's dive in. Also going to be using my multimeter to actually test the waveform of the output of this inverter to actually see if it's actually pure sine wave, which they normally claims. You're gonna love this video. Okay, moving on to the inverter spec, because the first thing which actually we saw is actually the cooling fan. Yeah, this cooling fan helps to reduce the heat into the inverter, like to send out the heat out to make the inverter cool, as they say. And also you can see the battery terminals right there is actually connected to the battery. And moving on, we can see the AC output. Yeah, this is the AC output, which output the 250 volts as they say, and also some kind of 2 amps USB which you can be able to use to charge your phone to power other stuff, and some kind of switch right there which actually turn on the inverter or turn off the inverter, and also the 6000 watt which actually the claim the inverter is, which I definitely don't believe. But too bad for me, I really don't have a battery which can be able to handle that kind of current. If not, I could have tested and check it out. But anyways, we are still going to power some stuff, and also you can see the LCD screen. Not actually the LCD screen, actually the screen that shows the current draw, the battery current, and the voltage output, all this kind of stuff. And also the fake body that actually looks like a heat sink, but it's not actually heat sink, it's pure plastic. So yeah, these are the specs of the inverter. Let's go to the next one. Let's take a little review on the Chinese pure sine wave inverter. I almost forgot also some kind of guide on how to connect it, and like how to connect it if you're a new beginner in using inverters, but this is useless for me. I really know how it works, and definitely the connections though. Also, this inverter actually needs a 12-volt supply, which is going to be put into the inverter for it to function. And I'm going to be using this 12-volt battery, 7.5 ampere battery, to actually test the inverter. And yes, let's dive in. Checking the voltage of the battery, we saw about 13.11 volt, which is a good one, and 13.11 volt is actually a good one. But actually this battery is not really strong. Just testing it for the first time with this inverter. The battery was really dead. I tried waking it up, and some cells are not still good, so don't expect much from the battery. The inverter also comes with the alligator clip, so you got to be clipping to the battery for it to connect. Yeah, if you don't want to like twist wires together, you can just use this alligator clip to just clip to the battery to allow more current to flow. And yeah, every inverter must come with alligator clip. It's a must though. All set, let's test it out. Okay, we got about 225 volt at the output of the AC source. Anyways, the fan is not turned on yet. I guess it's when we draw a lot of power, that's when it's going to trigger the fan to turn on. But we're still going to test it with our meter to be sure. We're going to be testing the output AC voltage with our multimeter to see if it's actually really accurate. Let's go to that. Get about 255 volt on my multimeter, and we are having 225 volt on the inverter meter, which is like 30 volts difference. But anyways, that doesn't matter. All what matters is the pure sine wave which we're about to test. Stay tuned to that. Anyways, finally the moment of truth. Oh my god, modified sine wave at the output. Holy crap. They actually say these inverters produce pure sine wave on these AliExpress store, but to my surprise, we got modified sine wave out of this, then oh my god, this is not really surprising to me because I know that the inverter is not really that costly, but the way they say it is actually pure sine wave really freaks me out. But anyways, all good. I know some components and some equipment can still run a modified sine wave, but some sensitive equipment and equipment we blow up like a computer system really sensitive to that. I don't really know, but yeah, all good to me, really good to me. Can power up my lab and so, but it's really a downfall of actually saying it's actually pure sine wave, but it's not. Also, with the output frequency of about 52% and 52 Hz, then actually 50 to 49 to 50% dual cycle, which we got on the output, which is pretty cool and pretty nice, still usable. Yeah. Anyways, we got the first starting draw of about 137 milliamps, and as the inverter turned on completely, we have about 457 milliamp drawn from the battery. Yeah, it's really cool. About not really cool, bull, but not is connected, and the inverter is already drawing close to 500 milliamperes. Not really impressive though, but let's just keep going. Moving on, testing other equipment, we check out the 5-volt LED, which draws close to 2 amps from the battery, which is actually connected to the 5-volt supply, 5-volt USB source, which is on the inverter. 2 amps from the battery. Oh my god, that's a lot though. That's not even gonna last more than 4 hours. Really high. Also got about close to 1.5 amps drawn from the battery when a 5-volt 2 amps charger is connected to the AC supply. Pretty nice. And the last but not the least, we're going to be testing the super 30-watt soldering iron. Yeah, I'm going to be connecting the soldering iron to the AC supply of this inverter and see if it really works. You know, in my last video, I said the other soldering iron which I tried to turn on didn't work. So I'm going to be testing out this soldering iron 30 watt to see if the inverter can take it. I know my battery is not really strong, so I'm going to get a little failure in this. It will be a success, maybe, if I have a good battery. Anyways, let's just do it. Oh my god, we got about 2.3 amps drawn from the battery when a soldering of 30 watts is connected, which is pretty nice though. I really didn't expect that. So are you telling me that the last first LED which I actually tested is drawing close to 30 watts? What the frick? That bulb really needs a resistor, but really cool though. Oh my god, without even a glitch, the inverter shuts down because the battery go below 10 volts. This is really disappointing. Anyways, let's just check the temperature which my soldering went to. There comes the item which I actually didn't want to tell you about. It's actually the temperature checker. I got it from actually a phone cooler. Yeah, I got it from a phone cooler. So you just need to power off the 5 volts and it's gonna check the temperature for you. If you place the thermal stuff on top of anything that's getting hot, it's gonna read the temperature for you, and LCD 7 segment display right there. So let's just test it out. Oh, we got about 50 degrees, close to 50 degrees heatness from the soldering iron. Really not really nice, and this can be able to melt any stuff. But I think we need a strong battery for it to get more hot, I guess. Okay, I think it's time for the tear down into the inverter. Yeah, we're going to be opening the inverter to actually see what is inside, how what is connected, and how it's made. But first off, I'm going to make a brief explanation on how inverters are made. First off, we have the oscillator. Yeah, the oscillator is actually the frequency generator which is going to be driven, and maybe some kind of using a 455 time IC chip or different ICs which produce frequencies, actually PWM frequency. So this section is actually the oscillating section, and the second section which the oscillating section goes to is actually the driver. Yeah, these are the MOSFET drivers which takes in the PWM signal, and the third section which I'm going to be showing you is actually the MOSFET chat. Yeah, these MOSFET are going to be doing the switching job for us to get the desired frequency and wavelength and all this kind of stuff. And finally going to the transformer. Yeah, the transformer is actually used to step up that oscillating voltage to a higher voltage, which can be able to power appliances and other stuff like that. This is just a brief explanation on how inverters are. I'm going to make a full video in the future talking about inverters and maybe build one. Stay tuned to that, and if you don't want to miss that, subscribe to my channel. I really appreciate that. Okay, firstly, looking at the inverter body, we have about 4 nuts here and 4 nuts here and one at the side, and actually 2 nuts for the fans. Totally, took about 11 nuts. Anyway, we're going to open it. It's really stuck in here. You know what? I'll resume when I'm done opening. Okay, we finally opened the inverter. Oh my god, this is really nice. Right here we have the USB circuit board. Actually, this is the USB side, which is actually the USB side 5 volts, and we have the AC terminal right here, which is actually the AC output, and this is the terminal which is actually connected. I remove it from the board, and also this is the cooling fan which actually cools the system when it's really hot. And moving on to the battery terminals. Oh my god, look at it, it's really thick. Yeah, they make it thick so that it can be able to draw a lot of power from the battery. Moving on, check out the MOSFET though. Wow, we have about 4 MOSFETs in layers. Yeah, this MOSFET actually is definitely the MOSFET which does the switching jobs for, yeah, the switching jobs. Yeah, this MOSFET really get hot, so they have to put some kind of heat sink to make it cool, and that is where the fan is actually also placed. The circuit board looks really small to me, bro. Yeah, because of the high frequency transformer, the circuit looks really small, other than UPS, which are actually really big and still not be able to deliver a lot of power. Okay, the circuit is really nice and small. I really appreciate it, and also appreciate the fan. The fan is really small and thick. I guess it's a 12-volt fan actually used. Yeah, this fan really play a good role when they draw a lot of power in the circuit. It helps to cool down the circuit, and also a good circuitry though. These terminals are actually battery terminals. I guess so. I guess. Yeah, a lot of components to salvage in this shit when it's actually destroyed, but anyways, just kidding. It's really nice and portable. I really like it. I really give a good credit to the selling of the thing, the soldering and everything. It's really nice though. Moving on to these caps, I guess these caps are actually used for filtering. Yeah, it's really long though, but actually I guess it's used for filtering. Its main work can be used for filtering, and you can see the MOSFET. Yeah, these MOSFETs are not in heatsink though. Maybe do we not really get hot? That is why they don't care to put the heatsink on it. But maybe they may be doing one part of the job, and the other may be doing the other part of the job. But anyways, we have also bridge rectifiers right here, 4 diodes, I guess, to change the voltage from AC to DC to power that USB 5-volt source. I don't know, maybe, I guess that is what it's used for. Also the high frequency transformer right here, which does the 100% of its job. Not really 100% of its job, but actually to convert the AC low voltage into the high one. And I guess so, yeah, high frequency transformers, and also other valuable SMD component which I can see, and maybe if I get a schematic I will see it. Really good board soldering though, really nice and portable. It's really small and portable, right? Okay, I think we're done. It's now time to close everything up and seal everything up, and I hope it works when I join everything together. I hope it really works. I really appreciate the soldering, as I said earlier, and also the setting of the components and everything. It's really nice, but the failure is that they said it's pure sine wave, but it's actually not pure sine wave, and I got modified sine wave. Also, I will make a test of checking the waveform when I plug a load. I'm going to be posting that in my Patreon, so if you want to join my Patreon, check out the link in the description below. To join my Patreon, I'm going to be posting some video ideas there too. The component is really nice set, and the value is really good. I really appreciate the setting and the soldering. It's really nice though, but the 6000 watt which is actually right here is not really true. I'm taking it as a 600 watt instead of 6000. I'm taking it as a 600. Yeah, looking at the components and everything, I don't think it can be able to withstand 6000 watts. 6000 watts, that means it can withstand 6% iron. Nah, it's not possible though. It's mostly maybe 600 watts. Maybe if I get a much stronger battery, I would test the watt and see how much it can deliver. I really don't have a strong battery. I'm gonna be trying to get a strong battery maybe some few weeks time and see if I can get a strong battery, but I really need your support, guys. We need to buy component. This inverter right here is not actually mine. It's actually my brother's own. He got it from someone. I really just want to make a review of it. Please help support me on Patreon for me to help me get components, and also a lot of stuff which I actually need. Also created a campaign on getting a new device for my channel, because those devices really give me a lot of issues in editing, camera stuff, and just I posted a link. Help me support, and I appreciate that. Okay, I think we close up the inverter. You can hear some music in the background. Don't mind about that. We really close up the inverter. It works really fine, and I tested it. It works really fine. All thanks to me. I'm really a good engineer. Support me on Patreon. I say it again. Thanks.